Hello again. Starting with some content this time, let's start working our way through some programming in Coq. So by now your tools should be well set up. If they aren't, you should go on Zulip and figure out what's wrong. But for now, if you can open up your day01 intro.v in Coq and type Control-C, Control-N, and some kind of thing like that shows up and everything loads, you're good to go. Okay, let's actually get started. Uh, we are in the textbook right now. I'm looking at the file y'all will download. Often I'm going to lecture out of a shorter file, but this time I'm going to use this one. I'm going to skip past a bunch of text, but you should not do that. You should read all of this text and make sure that you understand it as well as you can. What I want to do is skip past, Control-C, Control-Enter, and start talking about the actual code that we want. Okay, so Control-L is cycling my view right now. I'm going to try to tell you what Emacs commands I'm doing. And that's just to let me sort of change where I am on the screen without having to touch the mouse. I try not to touch the mouse at all. Okay, we're going to get started doing some definitions. This course is really going to be about giving some definitions and then later proving things about those definitions. That's really all we're ever going to do. So to start with, we have to be able to write definitions. All we're really going to do for the first 5 weeks is write definitions and then test them to make sure they do what we think they do. Okay, so to start out, I want to start defining a concept that we're all familiar with, and then we'll move into less familiar concepts. We're going to start by defining a data structure, a data type, for the days of the week. Okay, so here's the Coq definition. There are a couple parts. This part highlighted in green here is a keyword introducing what's called a vernacular command. These vernacular commands are instructions to Coq to create definitions or to check something or to do something. They're sort of these imperative, hey, please do this. The programs we write will be in a language called Galena, and I'll try to distinguish what is a Galena term and what's a vernacular command. This is a vernacular command saying, I'm defining a new type. Inductive is how you introduce a new type, right? It's how you say, hey, I'm going to define a new set of values that I care about. Here, this part in blue, that's a name. And then this colon says, hey, what kind of thing is day? And I'm saying, oh, it's going to be a type. That's what we're defining. And then the colon equal says, hey, here are the definitions. And each of them is a what's called a constructor. Monday, Tuesday, Wednesday. These are all constructors. They'll all construct things, produce things of type day. And then there's a period at the very end to say, hey, I'm done with this vernacular command. Every vernacular command ends with a period. These pipes, or bars, separate each of the options. So you can read this as saying, okay, there is a type, it's called day. It has 7 possibilities: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Those are only and exactly the possibilities of things that could be a day. There's no blurs day, no fun day, none of those. Those are right out. Okay, that's how you define a type. Let's work with the type. We're going to define a function next weekday. The way next weekday works is you give me a day, I'll tell you the next weekday that comes after it. So most of the time that'll just be the next day. Sometimes it'll be a few days after that if we're looking at a weekend day. Okay, how does this work? Well, first let's make sure that our definition was accepted. Control-C, Control-N advances one vernacular command. And then you'll see something appeared down here. Day is defined, and then a bunch of other crap is defined. We don't know what any of this means. We're actually not going to talk about this stuff at all in the rest of the course. This is the things that make Coq work. They are not, in fact, telling you to get wrecked. This is part of how we'll define recursion and things like that. This window, the one here that I'm making my little symbol bigger in, we're not going to use for 4 or 5 weeks. Eventually, that's where we'll do proofs, but we're not really going to do anything there. So for now, all of our work's going to happen here in the definitions window, or the actual code window, and then we'll use this response window to find out how our vernacular command. So here it's basically saying, hey, your definition of inductive types looked really good to me, right? There's ways that we could mess that up, right? If we tried to give it 2 versions of Sunday, that's too many Sundays. And then we'll get a message that says something like, oh, the constructor name Sunday is used more than once, which is their way of saying each constructor name here has to be unique. Okay. I should add, all constructor names have to be unique everywhere, right? You can't have we couldn't define another day type and use, Monday in that type also, right? Well, there can be only one thing named Monday. Okay, back to definitions. Here's a function next weekday. The keyword definition says, hey, I'm going to introduce an ordinary definition. Here's its name, next weekday, and it has a parameter, right? It takes an input. That input is of type day. The colon here is thing, colon, and then you give the type. So D is of type day is a parameter to the definition next weekday. It's a function. It returns day. Next weekday of D will be an expression of type day. How do we define it? Well, here we go. Colon equals. Okay, colon equals, then we say match. Match is a way of asking, hey, I'd like to do case analysis on some inductive type. So D is of type day. We see up here, D is our parameter. Day is defined inductively, so we can do a match on it. What should show up in these match? They're called patterns. Here, each of our patterns is exactly a constructor. Right, so we say, hey, is the constructor Monday? In that case, the next weekday is Tuesday. Is it the constructor Tuesday? In that case, it's the next weekday Wednesday. This arrow is saying, if this case matches, then I want you to run this code. And Coq has a sort of top-down approach where if you have more than one match, it'll do the first one. Here, all of our matches are what I would call disjoint because we've just named all the constructors and all the constructors are different. You'll notice we're, I think, correctly computing the next weekday because for Friday, the next weekday from Friday is Monday. You have all weekend to not have a weekday, and ditto Saturday and Sunday. All right, so the syntax here is match, and then the scrutiny, the thing you're doing the match on, and then with, and then a list of pipe-separated alternatives where you write pattern, the thing you want to match, and then an arrow, and then the thing you'd like to do in that case, and then end, and then period. Now let's see if Coq accepts this definition. Looks good. What if we left one out? Error. Non-exhaustive pattern matching. No clause for pattern Sunday. Okay, Coq will, and you'll notice the blue didn't advance. Coq will not let us define something that leaves out critical patterns. Okay, so much for that. There's a definition. Let's learn one more command, two more actually. The check command lets you ask the type of something. So we could say, hey, what type is Friday? And then over here in our response window, it says, oh, don't you know? Friday is a day. Oh, what good news. So again, we're seeing in this response window the blah colon blah, meaning thing is of type blah. All right. A convention that we'll use is we'll often, when we want you to notice the result of a vernacular command, we'll write it in the comment right after. And if they're different, then they're either you've done something wrong or we've done something wrong, and we should find out which. Okay, you can write a compound expression in a check. Say, hey, I have this more complicated expression. What type does it have? Ah, well, without telling you what the next weekday from Friday is, I'm not going to compute anything. I can tell you in advance that it will be a day. We don't know what it is. There's no way to know what weekday comes after Friday, but it will be of type day. Okay, if you want to know the answer, then you use compute. Compute will run your program as far as it possibly can. And here it uses this notation, says equals Monday colon day. So here's a case where the thing we wrote here is not exactly what Coq is going to produce for you. That's fine. Nobody's worried about that. Right? And again, you can write super compound expressions. Here, we can write a longer function application where what's the next weekday after the next weekday from Saturday? And if you do it in your head, you'll be like, okay, well, Saturday, the next weekday is going to be Monday, and the one after that will be Tuesday. So let's double check that we got it right. Okay, looks good. One other thing worth commenting on is the way we apply functions here is with a space, right? You could, if you wanted to, write this. That'll type check, but you don't need those parentheses. This, in Coq, is weird. Right? You'll see later on that we're just going to have some slightly different notations for working with and applying functions, and that's just a functional programming thing. That's the way that it goes. Okay, that's all I really want to talk about in this video. Hopefully you can follow along. As we go further on, we'll talk about other data types and some more interesting functions. Okay, talk to you soon.